problem 31, they ask us to find the surface area of this figure below. Now, let's look at this. Let's first look at, or think about, if we just had the cylinder, if we were going to do the surface area of the cylinder. And remember, surface area is that part of the surface that you can actually see. So if we were going to do the surface area of a cylinder, the surface area of a cylinder would be 2 pi r squared, that'd cover the top and the bottom, plus the lateral part, which would be 2 pi r h. But we have to then look and consider that this part is not visible. It's covered. So we'll have to subtract that. So that would be minus that circle that's covered there, pi r squared. And then we would have to find the surface area of a cone. Now this would be just the lateral area of a cone. So the surface area of the cone there would be just the lateral area of the cone, which would be pi r l for the cone. Okay, so let's look and see the radius here. It's going to be half of 20 feet. It's going to be 10 feet. That's the radius of our cylinder. The radius of our cone here, let's see, we have 3 feet here and 3 feet here. That's 6. If I subtract 6 from 20, I get 14. So if I divide 14 in half, that'll mean the radius here is 7 feet. Okay, so let's fill in. So we've got 2 pi. Now, r for the cylinder is 10 squared plus 2 pi r for the cylinder is 10 times the height of the cylinder, which is 6, minus pi times r up here for this circle. R is 7 squared. So here we're going to have 10 squared is 100 times 2 is 200 pi plus, here we have 6 times 10 is 60 times 2 is 120 pi, 20 pi, minus 7 squared is 49 pi. So if we put this in our calculator, let's see. We have, if we add these two together, get 320. So 320 minus 49. So that's 270. So surface area of the cylinder is going to be 271 pi. Now, let's see about the surface area of the cone. So for that, we have pi. Now, the radius of the cone is 7 feet. Now, the slant height, we don't have the slant. Yes, we do have the slant height. It's 8. So that's going to be times 8. So the surface area then of the cone is going to be 56 pi. So we have to add that to this. So the surface area total is going to be 271 pi plus 56 pi, and that's going to equal 327 pi. So the surface area total would be 327 times second pi, and that would be 1027.3 feet squared. That would be the surface area. Okay, let's move to the next one. So on the next one it says, find the diameter of a hemisphere that has a volume of 4,601.39 meters cubed. So a hemisphere, that's half of a sphere. So the volume for a hemisphere is 2/3 pi r cubed. So here now they tell us the volume, 4,601.39 is equal to 2/3 pi r cubed. So we're going to divide each side by 2/3 pi. 2/3 pi. Okay, if we do that, we find that r cubed is equal to. Now, let me see what 2/3 pi is. So I've got 2 divided by 3 times pi. That's 2.094. So I'm going to take 4,601.39, and I'm going to divide it by 2.0944. And that's going to give me 2197. So now I'm going to take the cube root of each side. So if I raise this to the 1/3 power, that's going to give me 13. So R is equal to 13 meters. So that's the radius of the hemisphere. So the diameter would be 2 times that, or 26 meters. That would be the diameter of the hemisphere. Now let's look at number 33. It says the Luxor Hotel in Las Vegas is a square-based pyramid that is 646 feet wide at the base and 350 feet tall. So it's 350 feet tall. Now, if the outer walls of the hotel are covered in glass, what was the minimum amount of glass used for the exterior? So what they're asking us to calculate here is the lateral area of this pyramid, the lateral area. That's where all the glass is. Now, look at the figure. This is 646 feet. This is a square. It's a square-based pyramid. So this is also 646 feet. Each side measures 646 feet. Now, if we're going to look at the lateral area of a pyramid, we know that the lateral area is equal to 1/2 perimeter times the slant height. So we have to now calculate the slant height here. So if we calculate the slant height here, we're going to have to calculate this. So we know that 1/2 of 646 is 323. So from the center to here is 323, and this part's 350. So I'm going to use the Pythagorean theorem, and I'm looking for the hypotenuse. So I'm going to say that the second square root of 323 squared plus 350 squared, and that's going to equal 476.3. That's 476.3. What are we talking about here? Feet. Okay, that's L. That's our L. So now the other thing we need to calculate is the perimeter. The perimeter, there's 4 sides, and each one of them measures 646. So 646 times 4, that's 2584. 2584 feet for the perimeter. So we can see that the lateral area is going to be 0.5 times the perimeter, 2584, times the slant height, 476.3 feet. Now, let's do the math here. So the lateral area would be 0.5 times 2584 times 476.3, and that's going to give us 615,379.6 feet squared. So we have that many feet squared. Okay, let's move on to topic 6. Now, topic 6, volume and surface area of similar solids. Now, it says the volume says the prisms below are similar. Find the scale factor, the surface area ratio, and the volume ratio of the larger prism to the smaller prism. So if I take the larger prism to the smaller prism, we're going to be looking at, we take this right here, 27 is to 6. Now we can reduce this, because 3 will go into 6 2 times, 3 will go into 27 9 times. So that's going to be our scale factor of the larger prism to the smaller prism, 9/2. Now, the surface area ratio. So in effect, we're going to take 9/2 and we're going to square 9/2. So that's going to be 81 over 4. That's going to be the surface area ratio. Now the volume ratio, we'll take that 9/2 and we'll cube that. So if we cube 9, we have 9 raised to the third power cubed. That's 729 to 8. 2 times 2 is 4 times 2 is 8. So that's what they were asking us for there. Okay, the volume. The volume of a solid A is 28 cubic meters, and the volume of solid B is 1,792 cubic meters. If the solids are similar, what is the ratio of the surface area of solid A to the surface area of solid B? So we're talking about A to B. Now, we have the solid A is 28 cubic meters to the volume. That's the volume. The volume of solid B, which is 1,792. Now, so let's look at that. Can we reduce this? If I divided 1,792 by 28, what I get a round number? 64. So that's going to equal 1 over 64. So what we're saying here is that A cubed to B cubed is equal to 1 over 64. So now we're going to take this back to A over B. So if we're going to do that, what we're going to do is we're going to take this and take the cube root of 1 over the cube root of 64. And that's going to give us 1 over 4. So that's the scale factor, is 1 over 4. But they ask us, what is the ratio of the surface area of A to B? So that's going to be A squared over B squared. So that's going to be 1 squared over 4 squared. So that's going to be 1 over 16. So that's going to be the ratio of the surface area of A, solid A, to the surface area of solid B. Problem 36. So we'll look at problem 36. This cone A is similar to cone B with a scale factor of 3 to 5. So we have cone A to cone B. The scale factors are 3 to 5. The surface area of cone B is 725 square feet. Find the surface area of cone A. Now, if I look at the scale factors, cone A is smaller. It's smaller than cone B, because 3 is less than 5. So that tells me I've got to have a ratio. I'm going to take that 725 feet squared. Now I'm going to multiply it times a ratio, this 3 to 5 ratio. It's got to be a fraction less than 1 because cone A is smaller than cone B, so that's going to be 3 to 5. Now, this is surface area here. So if it's surface area, then what we're going to have to do is, let's see, that's the surface area. We have to square this, or we not? Square it. Okay, so let's see, what do we do if we do that? Let's see if this is going to work out. So we've got 725 times, in parentheses, 3 divided by 5 squared. Now, what does that give me? 261. 261 feet squared. So that's the surface area of cone A. Okay. Now let's look at the next one. So here we have these prisms below are similar. If the volume of the larger prism is 1,029 cubic millimeters, find the volume of the smaller prism. Well, let's see. Here we're looking at surface area. So the smaller to the larger here is going to be 80 over 245. Now we can reduce this, I know, by 5. So if we do that, we're going to get 16 here over 49. Okay. So this is A squared to B squared. That's 16 to 49. So A to B would be taking the square root of each of those. The square root of 16, square root of 49. So that would be 4 to 7. Okay, but now we're looking at volume. So we're going to, says, we're looking for the smaller prism. So this 4 to 7 is going to have to be in a ratio that's less than 1. 4 to 7. And this is scale factor here. So we're going to have to cube this and multiply it times the volume of this prism times 1029. So let's see if we can put that in our calculator. We're going to put open a parenthesis, put 4 divided by 7, close the parenthesis, raise it with a caret to the third power, and then multiply it times 1029. If we do all of that, my calculator didn't like that. Let me start again. So we had in parentheses 4 divided by 7 raised to the third power and times 1029, and I get 192 millimeters cubed. So that would be the volume of the smaller prism. 192 millimeters cubed. Okay, so let's look at the next one. So the next one says the volume of a cylinder is 97 cubic feet. If the dimensions are doubled, what will be the new volume? So if we're going to double those dimensions, so the scale factor is doubled, so it's 2. We're going to go to volume, so it's going to be 8 times. So if the volume is 97 cubic feet, we're going to multiply that times 8, and that's going to give us 776 cubic feet. That's the new volume, because we doubled the dimensions. Now 39 says the surface area of a triangular pyramid is 1936 millimeters squared. if the dimensions are multiplied by 1/4, what would be the new surface area? So we're going to take that 1/4, which is the scale factor, they're multiplied by 1/4, and we're going to go to surface area, so we're going to square that, we're going to get 1/16. So if we take what they had originally, 1936 millimeters squared, and we multiply that times 1/16, let's see what that gives us. 1936 times 1 divided by 16, and that gives me 121 millimeters squared. The new surface area. Let's look at number 40. So number 40 says solid A has a volume of 5,632 centimeters cubed. Solid B has a volume of 11 centimeters cubed. How many times larger is solid A than solid B? Now let's don't get confused here. We were talking about volume. They gave us the volumes of the two, and then they said how many times larger is solid A than solid B. Well, that gets back to scale factor, but we're in volume up here. So let's take this A. Let's take A to B. So that's going to be 5,632 over 11. And if we do the math there, we get 512. Okay, so what we're saying here is that A cubed is equal to 512. So if we take the cube root of both sides, if we take 512 and we raise it to the 1/3 power, we get 8. So the answer is 8 times larger. Okay, 41. How many times larger is the volume of a cylinder if the radius is multiplied by 5? So the formula for the volume of a cylinder, the volume is equal to pi r squared times the height. So let's assume something here. Let's assume that the radius is 1. Let's assume that the height is 1. So the volume then would be pi times 1 squared times 1. So the volume would be effectively pi. Okay, now let's look at the other case. This other case here, we're assuming that the radius is 5 multiplied by 5. The height is still 1. And let's see what the volume is. The volume is equal to pi times 5 squared times 1. So the volume is equal to 25 pi. So now, if we look at this 25 pi over pi, it's 25 times larger. 25 times larger. So the last one, number 42. How many times smaller is the surface area of a sphere if the radius is multiplied by 1/3? So we know the surface area of a sphere is 4 pi r squared. So let's assume that the radius, initial radius, is 3. So the surface area then would be 4 times pi times 3 squared. So that's going to equal 36 pi. Alright, and if we multiply it times 3, the radius would be, if we multiply it times 1/3, the radius would be 1. So the surface area, which we said was 4 pi r squared, would equal 4 times pi times 1 squared would equal 4 pi. So we can look at this and say that 36 pi over 4 pi would equal 9. So it'd be 9 times smaller. And that concludes the Unit 11 test study guide.